record. Okay, so how do we do number 5? Whoops, didn't mean to move that. Okay, get my pen back. Number 5, what degree is this? Any answers, guys? You feel free to unmute yourself and answer. What degree is that times that going to give us?
Is it 4?
Yes, it is 4. Good job. Okay, degree 4. So, okay, degree 4. So we got that because, hey, there's an x here, and then there's an x cubed here, right? So that's degree 4. So what do degree 4s look like? Anybody catch that? Basically a W, like W for Wakefield. All right, yay, Wakefield. All right, so it's a degree 4, it's a W pretty much, or it could be a, sometimes it could be like this if it doesn't have a lot going. It could be a parabola, but kind of a squared off parabola. Sometimes that happens, but when it's got lots of things like this, maybe a W. There's a negative out in front. So what do negatives do when we throw a negative out in front of any function, guys? What does that do? Going to flip it over, right? You're going to flip it. So now it's that W is going to become an M, like mountain, right? With 2 bumps in it. So to get your zeros, we have a few zeros here. So this is your first factor. So you're going to set your first factor, negative 0.1x equal to 0, right? That's the first factor. You set it equal to 0, use zero product property, and you solve. So I divide by negative 0.1, divide by negative 0.1. And x equals 0 because, so anytime you have an x out in front of parentheses, right? So you have parentheses, you have an x here, you have x whatever here, that's always going to be equal to 0. Your intercept is always going to equal 0. So it's going to go through the origin, right? The origin is the middle. That's 0, 0. Okay, it's going to go through there. Great. Now this one, the x plus 4 cubed means x plus 4 times x plus 4 times x plus 4. So this is not a double root, but a what? A triple root, because you have the same thing and they're all equal to 0. So if I do x plus 4 equals 0, what is that going to give me for my x? It's going to give me x equals negative 4 3 times. Do I need to write it 3 times? Not really, but this will show you. You need to indicate that it's a triple root, right? So at negative 4, which is way over here at negative 4, it's going to go through that point. Remember, when it's double roots, it's going to bounce off the point. But if it's a triple root, that's odd. So it's going to go through the point if it's a triple root, okay? So I know this is an upside down W or an M. I know it's going to go through this point and through that point. So maybe I'm going to make my graph like this. Go up, up, down, like here. Okay, maybe it's going to have a little bump right there in the middle, but it's not going to cross the x-axis. So let me make that a little darker. Go like this. And then put an arrow at the end. It's going to go up through the negative 4, like that, and then down. Okay, and we can double check it on Desmos. I'm not going to do it, but you could definitely do it. Okay, something like that. So that's a good sketch. All right, I'm going to clear this out. Go to the next one. Okay, next one. Let's see. Do my color, change my color to pink, and I need to scroll up. So, pen go away. Okay, number 6. Okay, this guy. This looks very factorable to me. Does it look factorable to you? Like, hey, factor me, factor me, factor me. It wants to be factored. If I can get my pen back. Okay, so how do we factor this? They both have x's in them. Oh, let's start with the degree. Always start with the degree so we figure out what it looks like. What is the degree for this one, guys? Somebody unmute yourself.
Is it 6 or 2?
You know what? I said 6 at the beginning last class period too, and then I realized it's not 6. It's only the highest power. You don't add them together. You only add them together when they're like in factored form like this. But this is not in factored form, right? There's no parentheses. So what's... So yeah, the highest power is 4, right? Whichever one is the biggest, that's bigger than that. So the degree is 4. So what do 4s look like? W, right? Is there a negative out in front? Is it going to be an M? No, because there's no negative. So it's going to be some kind of W, or it could be a parabola. Okay, well, let's factor this because this can be factored. Okay, so I'm going to erase that stuff that I made there. To factor this, what can we take out of x to the 4th and 9x squared? I can take out the lower power, right? The x squared. I can take out an x squared out of both of these. So if I take out x squared out of x to the 4th, I have x squared, because x squared times x squared equals x to the 4th. If I take out x squared out of 9x squared, I just get 9. When I multiply x squared times 9, I get 9x squared. So I want to set these equal to 0 and solve. So if you take the part outside the parentheses, you set it equal to 0, you solve it. That's a double root, right? Double root, because it's an x squared. When I solve this, I get x equals 0 twice. You don't have to write it twice, but you have to indicate it. You can if you want to. This is a double root, so it's going to bounce off of x equals 0 right here. Now this guy, this x squared minus 9, that can be factored again. That could be x plus 3 times x minus 3, because it's a difference of 2 squares, dots, I like to call it. Difference of 2 squares. X squared is a perfect square, 9 is a perfect square, it's a difference. So, hey, we could split that up. You know, we could take like the square root of that, the square root of that, and we get x plus 3 times x minus 3 equals x squared minus 9. Okay, so when I set this equal to 0, x plus 3 equals 0. I set this equal to 0, x minus 3 equals 0. We get x equals negative 3 and x equals positive 3. So those are my other 2 roots. So at negative 3, 1, 2, 3, right here, negative 3, it's going to go through there, and at positive 3, it's going to go through there. I know it's going to be W-shaped, right? So to make a W, I start up here, I go down, double root, so it's got to bounce off the 0. So I have to make like a little curve right here, and that's probably symmetrical. Okay, I'm going to make it symmetrical. This one's probably not going to be asymmetrical because this function's pretty like symmetrical. Maybe it is asymmetrical. I don't know. Maybe it goes for the, I don't think it does, but we could use Desmos, but that's okay. This is good enough for now. All right, we good with that one, guys? Now let's do 7 and 8. Okay, 7. This, what degree is this? What degree is this problem? How many? Yeah, how many x's are there?
4.
There's 4 x's. Good. So again, we're going to get another w, right? Degree 4 is w. So the way we get our zeros or our roots is we set each factor equal to 0 and we solve, right? So 0.2x equals 0. X plus 1 equals 0. X minus 3 equals 0. And lastly, x plus 4 equals 0. That's going to give us our 4 x-intercepts. When you solve this one, you divide by 0.2, divide by 0.2. 0 divided by 0.2 is 0. So again, we get 0 for an x-intercept. When I subtract 1 from this, I get x equals negative 1. So another 0 is really close to it, negative 1. When I add 3 to this, we get x equals 3, right? So here, 1, 2, 3, right there. And then subtract 4, menos 4. I used to teach math in Espanol a little bit, like, oh, how like 14 years, 15 years ago. And my Espanol is muy mal. So they had to teach me Spanish. It was pretty comical. Okay, negative 4. Okay, so I know my zeros are like that, and I know my graph looks like that. Do I have any double roots? No. So I'm going to start up here. I'm going to go down, 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 go through the point, go back up here, and then just do a quick curve like that, and then back up. And so my sketch looks something like that. Okay? So, muy bien. All right, so that's number 7. Last one. Okay. This guy right here, this has a lot of terms. 1, 2, 3, 4, 5 terms. What is the degree for this one? That should be an easy question, though. Okay, 2 answers in the chat, and you can unmute yourselves. 4. Moises, I hope you didn't purposely leave off the R. It's degree 4, right? It's whatever the highest power is. That's why we put the numbers in descending order. So this is the highest power. It's 4. So we don't care about the 3, the 2, the 1 to determine the degree. So again, what is our function going to look like if it's degree 4? W, right? Or it could look like a U, like a curved U, but with all these terms, it's not going to be a U. It's going to be a W for sure, because the more terms you have, the more bumpy it is. And it's probably more like that. It's probably going to be uneven because it could be like that, or it could be like this, but it's going to be some kind of uneven W. Okay. So let's, what do we do next? Okay. I don't know about you, but I can't factor this off the top of my head. We don't know how to factor this yet. And I don't know if it is factorable. And I think it is because we did it last class period. So we have to cheat a little bit here because it's not a test. It's not cheating, right? We're learning still. We're going to use Desmos. Oops, I did not. Can I undo that? Yes, good. Oh, I didn't know I could do that. Okay. Desmos. If I go to Desmos and type this in, x to the 4th minus 4x cubed, blah, 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 blah. Go to Desmos. Okay. Here's Desmos. Sorry, all this writing is going to appear here. Let me try something. Let me annotate, and can I redo? Yes, okay. Oh, there's the graph, right? So here's my graphs. If I click on the x-intercept, it'll tell me all the x-intercepts. -1, +2, +4. Go ahead and draw that graph. We could even get the maximum right here at like 0.775, 12 point. So it goes all the way up to 12 for its maximum, relative maximum, and then the minimum goes down to like -17 almost. Okay, so go ahead and sketch that graph and see how it's an asymmetrical W. So it's going to bounce through -1, 0. It's going to come up to like almost 112, go through 2, 0. That's 2, 0. Bounce down at 3, -17-ish. And then go up through 4, 0, and make sure you put arrows on your end of your graph. Desmos doesn't show you the arrows, but we are going to draw arrows on our graph. Okay, we good with that? So because I'm going to draw on here actually. So because this goes through -1, I'm going to write my roots. X equals -1. You're going to write it on your paper, right? X equals -1, X equals 2 is my other root, and X equals 4. Are any of those a double root? That one's a double root, right? How do I know that's a double root, guys? Because it bounces off. It doesn't go through it, it bounces off. If it bounces off, so x minus 1, x equals -1 is, when I do the reverse, is x plus 1 squared, because it's a double root, right? If I do x equals -1, I add 1 to both sides, add 1, that's x plus 1 equals 0. So, but it's twice because it's a double root. This factor, the x equals 2, that's x minus 2, right? This x plus 4, that's x minus 4. And let's see if we have enough x's. We have x squared, x, we have x to the 4th here. And the original problem was an x to the 4th, so that's good. So this is probably how you factor this. There might be a different a value. I don't know what the a value is right here, but if it's 1, then that's beautiful. We factored it, and we kind of used reverse Desmos to factor it. Okay, so that could be how we factor this problem, number 8, on the worksheet. And that's our little sketch. I knew it was going to look like that. I didn't know where the little x-intercepts, that x-intercept, that x-intercept, that was, though. Later on in the chapter, we're going to learn how to find this without Desmos. Okay, so that's the beautiful thing. Okay, guys, so that, I know you are sad that this is the end of the lesson, of this wonderful, wonderful lesson, but it's the end. So what you need to do is turn it into, oh no, I want this, you guys. You need to turn it into A29 classwork right there for today. Your homework is not due till Wednesday, and the reason I made it not due till Wednesday is because I want you to study for the test, which is Tuesday, next class period, the Chapter 7 logarithm test. And then this will be our Wednesday assignment. So I won't give you a different assignment. It'll just be 8 through 12, 15 through 17, and 21. Do on Wednesday. If you are busy on Wednesday, you have something to do, then do it on Tuesday or do it on Monday. But it is due Wednesday, 4 p.m. I'm giving you 5 days notice that this is due at 4 p.m. So I shouldn't get any emails that I can't get it done by 4 p.m. All right. If it's after 4 p.m., some points will be deducted and it is only accepted on Wednesday. So that is the homework, and that's the only homework you have. So let me stop this recording. Stop.